Hello everybody, so continuing the introduction to programming Bitcoin using the Programming Bitcoin book, we're looking at finite field division. So already we've used addition, subtraction, multiplication, and if you're familiar with modulus, these should have been relatively straightforward to understand. So addition, you just add and then it's modulus, subtraction, same, but subtract, multiplication follows the pattern. Division, more difficult. So let's just see how you can divide. So just scroll down. So you could have questions such as what's 3 divided by 24, where the field is 31, the finite field length is 31. So what we need to do is use a formula. The other way around it would be to keep guessing which two numbers would produce you the result. That would be kind of brute forcing it. So finite field division, the intuition that helps us with addition, subtraction, multiplication, and perhaps even exponentiation, unfortunately doesn't help quite as much with division. Because division is the hardest operation to make sense of. We'll start with something that should make sense. So 7 times 8 equals 56 implies that 56 over 8 equals 7. So what you're doing is switching it. 12 times 2 equals 24. So 24 over 12 equals 2. So yeah, you can see how you can quite easily reverse those. So in F19, we know that 3 times 7, the little f just means that's we're using finite field. So 3 times 7 equals 21. 21 mod 19. So 19 goes into 21 one time with remainder equals 2. That implies that if you move the 2 across, then you've got 2 over 7 equals 3. Here you've got 9 times 5, 45, mod 19 equals 7. So 7 over 5 equals 9. In the same way as if you just had kind of 2 times 3 equals 6. So then 2 equals 6 over 3. You're just moving across the other side of the equals, sort of basic maths. That brings us on to the description of Fermat's little theorem, which, yeah, there we go. It's easier to actually do than it is to understand all of this formula, really. Obviously, this is just proof if you're a mathematician, but we're interested in how you can do it, or I'm interested in how I can use Python to solve it. So here we go as an example. 2 over 7. So really the formula here is 2 over 7 equals 3. So if you walked up to somebody in the street and you said, what's 2 over 7? They'd say, oh, it's probably some number around about sort of 0.3 or something. No. 2 over 7 equals 3. So here we go. What you actually do is you multiply the top number by the bottom number, but then you do the bottom number to the power of the prime minus 2. So here's where I've got my example, which there we go. So let's move that across slightly. There we go. That's looking different on. I'm going to make this full screen. There we go. So 3 over 24. What is 3 over 24 where the finite field length, the prime, is 31? So this is using Python, POW. I'll just comment these two out and we'll just do a basic POW example to start with. So let's do POW 2, 3. So this is just the standard built-in Python function. That gives us 8. So it's 2 times 2 times 2. That's the number you start with, and that is the power operator. So let's just go a bit further. So let's do it to 5. And that should give us what? Should give us 32. Yeah. So then what we could do with the POW, the proof, not the proof of work, sorry, the power operator in Python, then you can put in a prime number. So if we wanted to say what's so the modulo operator, so we could put in, if we put in 10 here, no, let's put in 9. So 3 9s are 27, so that should give us a remainder of 5. So there we go. Okay, so that's a very basic example. So using it to do division in a finite field, the question is, what is 3 divided by 24? So we do 3 multiply, and then here's the important bit. So we say that's the bottom number, and we do the bottom number to the power of the prime, which is 31, minus 2. So it's going to be, actually it's going to be 24 to the power of 29. Let's actually do that then. We'll do, if we do 24 to the power of 29, and then the prime, which we know is 31. So that should give us 30. Now we need to do 3 times that number. In a minute, we should end up with the same result as what I've got above. Just put it all in brackets, tidy it up. So there we go, the answer is 66. But what we also need to do is do the modulo there. So modulo 31, 66. So let's comment that out. And let's just see what we get here. We get 4. So what's gone wrong? We've got 3 times POW 24, 29, 31 modulo 31 equals n. Comment those out. Unmatched closing bracket. Bracket the start. Yeah, so there we go. I've just kind of put in the actual numbers instead of the prime. So yeah, this is all building up to doing elliptic curve cryptography in the next chapter. So whether you need to be able to memorize this and do this off the top of your head, I don't know. But here we say exercise 8, 3 over 24. So 3 times 24, and in brackets, you do 32 minus 2. So the important thing is to do minus 2 from the prime, and then do your multiplication. And then, so really, 2 over 7 equals 3. 7 over 5 equals 9. Again, this all leads up to chapter 2, which is elliptic curves. You may have heard of elliptic curves. In Bitcoin, there is a standard elliptic curve, which if I scroll down, it is, so this is kind of a prototype for elliptic curve. And the thing is because you've got y squared here, even if it's a minus number, it works, but it's just on the opposite side of the x-axis, so you get kind of a symmetrical shape. There we go. The elliptic curve is also listed again because of the y squared term on the left hand side, so you get the mirror image. Just going to scroll down and just show you the, here we go. If you read deeply about Bitcoin, you'll find out that you've got STCP 256K1, and this is the equation: y squared equals x cubed plus 7. So in due course, when we move ahead, So I'm trying to learn all this from scratch as well. So I'm sure there's far better tutorials than this out there, but this is just kind of showing me documenting my understanding and learning of programming Bitcoin. So clever bit here is where you've got a line, you've got an X and a Y coordinate, which here and then there, which produce you a here we go. So if you've got some points, you can plot a straight line, and then that straight line intercepts the curve, and then you can do some clever stuff by adding A plus B, and then it kind of mirrors it, and then you end up with a point down here. So point addition. So yeah, a lot more reading to do so far, but I just thought I would clear up the division, which is, as we read, not quite as straightforward as addition, subtraction, multiplication. And then what we will do is we will move on to looking at this, and I will try and write some, or there's some Python examples here within. If you go to Jimmy's Song, search Bitcoin, search GitHub for Jimmy's Song, you'll find his repo. You'll find the repo for this, and there's some Jupyter notebooks in there. But really, I want to understand the concepts before I start writing too much or editing and copying too much Python code. Especially copying it is dangerous because you just copy it, you run the button, and you don't really remember it. You need to write it from scratch. So yeah, there we go. This is the intro to elliptic curve cryptography. So A, point B, you keep going, it gives you line C, and then C equals A plus B. And the whole point of this is to give you some secret numbers which you can then use to do your cryptography with, which will then give you public and private keys, which form the basis of cryptography, or what is it, RSA and asymmetric encryption, where you have a public key which you can send into the big wide world, and then you have a private key which you never share, and then those two keys work together. So I'm thinking that's what we will get to here ultimately. Maybe it's going to be, yeah, chapter 3, elliptic curve. So I'm skipping ahead a bit here. So really what I just wanted to show here today was using prime numbers and using POW with Python. So yeah, all that looks like it'll produce a really big number, doesn't it? 24, 29, 31, mod 31, 3 to the power of. And all that ends up giving you is a number 4, which is, I think that's quite amusing. Interesting, whatever. So yeah, thanks for watching. I know this is quite niche, so I'm going to kind of alternate these videos with more standard Python stuff. But if you just want to kind of just follow along to my progress, then please just watch these videos, thumbs up, ask questions, whatever. And if you're kind of just learning kind of some of the theory behind Bitcoin as well, then yeah, let me know. So thanks for watching. Thumbs up if you like it. Thumbs up even if you don't like it. That would still help me. So yeah, see you again. Thanks.